Bismillahirrahmanirrahim. Now we're going to continue our solved examples of dynamics integration of vector function. Here we have this example. Identify which of the following curves from A, B, C is corresponding to displacement, velocity, acceleration of a body moves in a straight line. Okay, here we have a curve included. This sketch we have three curve. It belongs to the motion of a body in a straight line. It's required to identify which one of these three curves A, B, C belongs to velocity and displacement acceleration. Okay, the way to solve these kind of problems is as follows. You find first any curve having a maximum point, for example this curve B, and from this maximum point or top point we can use or we can draw or sketch or sketch this horizontal line parallel to x-axis. Okay, as here. Okay, this tangent and this is tangential point, for example point number 1. Okay, the slope of the tangent at point 1 is 0 as it's parallel to x-axis. Okay, as you know, the slope of this tangent is first derivative of this curve. Okay, then we have here b dash at point 1 equals 0. Okay, the slope of the tangent to this curve b at point 1 equals 0, then b dash equals 0. Okay, from this point we can draw this perpendicular segment to x-axis. Okay, to meet this curve C at this point where C equals 0. Okay, then at point 2 at 2, okay, we have C equals 0. Then here we have C is corresponding to first derivative of P. Then we have C is P dash. Okay, this is step number 1, and we repeat with second or the rest of these curves. Okay, for this curve, for example C will it has this minimum value. Okay, or turning points, and we have here we can draw this we will consider this point as a tangential point, and we'll sketch here this parallel line to x-axis. Then we have here the tangency, the slope of this tangent and this point, for example point 3, okay, equals 0. Then C dash as the slope of this tangent is the first derivative of this, the equation of this curve. Then we have C dash at point 3 equals 0 also, as the slope is of this tangent is 0 as it's parallel to x-axis. Okay, from this point 3 we can draw this perpendicular segment to x-axis and meet curve A at this point, for example point 4. Okay, at point 4 we have A equals 0. Then we have here A is corresponding to C dash. Okay, this second step. Also, as we have three vectors, we have displacement x, okay, and we have velocity and we have acceleration. Okay, and we have v equals x dash, and we have also a equals v dash. Okay, acceleration is first derivative of v. Okay, now we can compare between this result and this one. Here we have v equals x dash, and we have here also c is b dash. Okay, then and we have here v and v dash, and we have c dash. Then we have here c is v is velocity curve of the curve of number c. Number c is representing the velocity of this body moving in a straight line, and we have here b equals or corresponding to x. Then b is the displacement, okay, of this body, and finally we have acceleration is a. Okay, curve number a is acceleration of this motion. We have another example. A body moves in a straight line according to the relation v velocity equals 3t squared minus 2t meter per second. Find distance covered during the time interval from 0 to 2 seconds. Okay, here we have it's required to find distance. Okay, then we have to find or identify at which time the direction of motion changed or not, and if it's included in this time interval under investigation or not. Okay, then we have find v. equals 0 first. We have 3t square minus 2t equals 0. Then we have here t, 3t minus 2 equals 0. We have t equals 0 at first, t equals 0 at the start of motion, and we have t equals 2 over 3 seconds. Okay, and this times included in this time interval 0 to t. Then we have here x equals modulus of integral of v dt, okay, over first interval from 0 to 2 over 3 second, plus modulus of v dt integral from 2 to 3 to 2. Okay, then we have x equals this modulus integration of v here, integration from 0 to 2 over 3t square minus 2t dt, and we have also from 2 over 3 to 2 3t square minus 2t dt. Okay, and we have this modulus. Okay, by executing this definite integration, then we have here modulus, here we have t power 3 minus t square, okay, from 0 to 2.3, and this modulus. And we have also second modulus, here we have t power 3 minus t square from 2 over 3 to 2, and we have this modulus. Okay, here we can substitute by 2 over 3 and subtract by substitution of t equals 0. Then we have this modulus, we have 2 over 3 power 3 minus 2 over 3 power 2, this first one, minus 0, this first modulus, plus second one is substitute by 2, then we have 2 power 3 minus 2 square, minus here we have 2 over 3 power 3 minus 2 over 3 2, and this is second modulus. We can use the now calculator to find the result of this calculation. Then we have here x equals 116 over 27, okay, meter, and this is equals 4.3 meter. Okay, secondly, it's required if it's required, now this is required. Okay, if it's required to find displacement, okay, displacement here during the time interval from 0 to 2, then we have to use the displacement s equals integral of v dt from 0 to 2. Okay, then we have 0 to 2 v 3t square minus 2t k dt. Then we have here this definite integral t power 3 minus t square from 0 to 2. Then we have here 2 power 3, okay, minus 2 power 2 minus 0. By substitution here t equals 0, then we'll find 0. Here we can find displacement equals 4 meter. Okay, it's clear that x is greater than s. We have x equals 4.3 meter, and we have on displacement only 4 meters. Then we have displacement distance is greater than displacement, and this is as a rule, x is greater than or equal to distance is greater than or equal to displacement for a body moving in a straight line. We have another example. If v velocity equals c power 3 minus 3t square plus 2t, find distance over time interval from 0 to 3. Okay, as it's required to find distance, and we need to find if the motion direction changed or not during this time interval when v equals 0. Then first we'll find when v equals 0, then we have t power 3 minus 3t square plus 2t, this is equal 0. You have t square minus 3t plus 2 equals 0. By factorization we have t minus 1, t minus 2 equals 0. Then at t equals 0 and t equals 1 and t equals 2, the velocity vanished or velocity equals 0. Okay, and all this time interval included in this 0 to 3 time interval under investigation. Then we have here displacement distance equals integral of v dt plus integral of v dt plus integral modulus, of course, integral of v dt, as x is always positive. Here first interval from 0 to 1, from 1 to here from 1 to 2, and here from 0 to 3. Okay, then we have x equals integration from 0 to 1v t power 3 minus 3 t square plus 2t, okay, dt, and we have also the same modulus of integration from 1 to 2 t power 3 minus 3t square plus 2t dt, and this modulus, and we have also plus modulus from 2 to 3 t power 3 minus 3t square plus 2t dt. Okay, now we can execute this definite integral. Then we have here modulus integration of this one is t power 4 over 4 minus t power 3 plus t square. Okay, this is from 0 to 1 and this modulus, and we have the same this quantity of t power 4 over 4 minus t power 3 plus t square from 1 to 2, and this is modulus, and finally we have this last modulus t power 4 over 4 minus t power 3 plus t square from 2 to 3 second. Now we can substitute by upper term minus lower term in each of these integration. Then we have here by 1 we have first bracket 1 over 4 minus 1 plus 1 and minus 0, this first modulus, and second modulus here we have this one we have substitute by 2, then we have 1 6 over 4 minus 8 plus 4, okay, this first bracket, minus 1 over 4 minus 1 plus 1, this second one, plus last one we have here 3 power 4 over 4 minus 3 power 3 minus 9, okay, this first bracket, plus here we have 1 6 over 4 minus 8 plus 4, okay, and this third one. By using calculator we can simplify and find this summation. Okay, we have here x equals 11 by 4 meter, and this is required to find. We have another example. If a equals 3, v naught equal -1, find distance covered over the time interval from 0 to 2 seconds for a body moves in a straight line. Okay, here we have v. First we can find v from integration of this given acceleration. V equals the integral of a dt. Okay, then we have integral of 3 dt, then we have 3t plus constant. Okay, to find constant at t equals 0, we have v equals v naught equals -1, c equals -1, v equals 3t minus 1. Okay, it's required to find the distance covered. Okay, to find distance we need first we need to find if the motion direction changed or not at v equals 0. Then we have 3t minus 1 equals 0, then t equals 1 over 3. At this time the velocity equals 0 and the motion direction changes. Then we can find the x equals the modulus of integral of v dt plus integral of v dt. Okay, modulus of course here from 0 as t included in this time interval under investigation. Then we have 0 to 1 over 3 and from 1 over 3 to 2. Okay, then we have here modulus 0 to 1 over 3. V integration of v, okay, is here 3t minus 1 dt and plus from 1 over 3 to 2 3t minus 1 dt. Okay, modulus. Then we can find or execute this definite integration. Then we have here 3 over 2 square minus t, okay, from 0 to 1 over 3, and we have also the same 3 over t over 2 to t square minus t from 1 over 3 to 2, and this is modulus. Okay, then we have by substitution here by t equals 1 over 3, 3 over 2, 1 over 3 square minus 1 over 3. This first one minus when we substitute by 0 t equals 0, then we have here 0, this first modulus, plus second modulus we substitute first by t equal 2, then we have 3 over 2, 2 square minus 2, this first bracket, minus substitute 3 over 2, okay, when t equals 1 over 3, okay, minus 1 over 3, and this second modulus. By using calculator we can simplify and find the result of this summation. Then we have x here, x equals 1/3 over 3 meter, and this is required to find. We have this problem in figure. The curve representing the relation between velocity and the time of a body moves in a straight line is required to find displacement over the time interval from 0 to 7. Okay, as we know, the displacement, for example, x equals integral from 0 to 7 v dt, and this is equals area under the curve, okay, vt over the time interval from 0 to 7. Okay, here we have x equals, here we have three areas, this one and this one, and we have this one a1, okay, but x may be positive or negative. Okay, then we have here a1 is negative, okay, here a2, and this is a3 plus a2 minus a3, okay, as a2 is above x-axis, a1 and a3 is below x-axis. Then area or displacement here is negative, then x equals here negative, a1 is area of this triangle, half, we have base here 1 and height is 2, okay, plus here we have this trapezium. The area of trapezium is half base, upper base plus lower base times height. Okay, we have upper base here from 2 to 3, then we have here 1, okay, plus lower base from 1 to 5, we have 4. Here we have height is 2, okay, then we have to subtract the area of this triangle. We have here half, base is 5 to 7, we have 2, and we have height here we have 1, okay, then we have x equals, here we have negative 1, here we have plus 5, here we have minus 1, then we have 3 meter. Okay, you have to take care that it's required to find the displacement over the interval from 0 to 7. If it's required to find from, for example, from 0 to 5, then we will use this time interval only. Okay, then we'll add this negative a1 plus a2 only. Okay, and we'll remove this one. Okay, if it's required to find from here to from 0 to 3, then we are going to calculate the area of this triangle and the area of this shape, okay, from 1 to 3 only. Okay, you have to take care that over which time interval you are calculating the displacement. Okay, secondly, if, for example, it's required to find distance, okay, distance only over time interval from 0 to 5, okay, 0 to 5, then distance is always positive, then distance x equals the area under the curve from 0 to 5, but in with positive sign. Then we have the area of this triangle and the area of trapezium, both are in positive signs. Then we have here a1 plus only a2, as it's required to find the distance from 0 to 5 only. Okay, we'll remove this area. Then we have here area of 1 as here modulus, and here we have modulus also. a1 is modulus negative 1 plus modulus 5. Then we have here 1 plus 6, then we have 7 meter, 5, okay, we have 6 meter. 6 meter is the displacement moved by this or covered by this body during the time interval from 0 to 5 seconds. We have another example in figure. VT curve of a body moves in a straight line. Find this distance covered over time interval from 0 to 10 seconds. Okay, here we have x is the distance covered during this time interval from 0 to 1 equals the okay, modulus of v dt, okay, from 0 to 10, okay. But we have here 3 time interval from 0 to 1, from 0 to 2, and from 2 to 7, and we have from 7 to 10, okay. Then we have to find the area under the curve over each of these time intervals, and we use modulus as x is always positive. Then x equals, here we have area 1, area 2, area 3, then we have area 1 modulus area 2 plus area 3. Then we have here the area of this triangle have base is 2, height is 3, plus area of this trapezium of half, okay, base 1 plus base 2 multiplied by the height. Then we have base 1 from 3 to 6, we have 3, plus from 2 7 we have 5, we have height is 3, and all this is positive, okay. Plus we have area of this triangle half, base 2 to 10 we have 3, and we have height here is 3 as well, okay. Then here we have 3 plus here we have 1 2, and we have here 9 over 2. Then we have here 19.5, okay, meter, and this is the distance covered by this moving body during the time interval from 0 to 10, okay. If it's required to find displacement over time interval, for example from 0 to 7, as we said during explanation, you have to take care that of the time interval you are using, okay. In this example, use time interval from 0 to 1. For this one, if we only use this time interval or investigate the motion during this time interval from 0 to 7, as here it's required to find displacement over time interval from 0 to 7, then we are going to use the curve from this over this time interval, and we'll remove this one or cancel this part, okay. Then displacement here equals S equals the area under the curve during 0 to 7 by each sub interval with its sign, positive or negative. Here we have A1 positive, okay, minus A2. Here the area or the curve is drawn under x-axis, then we'll use area A here as negative. Then we have displacement here S equals A1 here is 3 positive, okay, minus 12, then we have negative 9 meter, and this is displacement moved or covered by the moving parts or body during time interval from 0 to 7 according to VT relation. Now it's required to test yourself by trying to solve this problem. A particle moves in a straight line with initial velocity negative 2 meters per second from a position distance 3 meters from a fixed point in the direction of motion, where A equals 2t plus 1 meter per second square. Find x when v equals 0. The correct answer is 11 by 6 divided by 6 meter. You have to solve it in details.